This video is about systems of equations, or linear systems to be specific. And again, this is kind of a basic, what is it about, what are we trying to actually figure out, sort of thing. So, in this particular system, it's a linear system. So look at number 5. It says y equals 4x minus 9 and y equals x minus 3. So these are in a system together. I'm going to put this curly bracket around it, meaning these two graphs go on the same axes, or the same coordinate plane. So if I were to graph these equations, right, they would make two lines. And these two lines, because they're not parallel, meaning they don't have the same slope, they're going to actually cross each other, meaning there's going to be a spot where they're going to meet. And when we solve a system, we find that spot where they meet each other. Okay? So that's the goal of what we're doing here. And this method that we're going to be talking about is particularly substitution. Okay? So you'll notice, like on number 7, do you see how y equals negative 5? So when we substitute, right, couldn't we plug in negative 5 for y, right? Because we know negative 5 is y. So usually we call it plug it in. But substitution is the fancy academic word we use to plug in negative 5 for y. And we'll do that with number 7. But with number 5, okay, we're used to seeing like, oh, x equals 3 or y equals negative 5. So what we can do is that same exact principle or idea of, oh, we can just plug in that information because we know what y equals. We know what x equals. Well, take a look at number 5. Y equals x minus 3. We know that, right? It equals x minus 3. So that's what y equals. Here's what we can do. All of this can actually get plugged in for y up top. Right? Because isn't y equal x minus 3? So that means I can plug that in, that information, to y. So that means I could write x minus 3 equals 4x minus 9. Right? Because that's what y equals. So I plugged in the information for y. You could have as well, if you didn't want to do it this way, well, y equals 4x minus 9. So you could have plugged it in down there. And again, that would give us the same exact thing as before. But it doesn't matter which way you go. Okay? So y equaled all that information, so I plugged in the entire expression in for y. And here's what this does. The reason why I'm doing this is now I only have one variable to solve. So notice how I have 4x and x, right? Y isn't involved anymore. So that means I can actually figure out what x equals because I've gotten it all by itself. And now we just use our basic algebra skills to actually solve. So I'm going to start by subtracting x over here, which gives me 3x minus 9 equals negative 3. I'm going to add 9 to the other side, which gives me 3x equals 6. Divide by 3. And x equals 2. All right? So I have what x equals. But in a system, again, the point is we want to find out where they cross. And as I said earlier, they cross at a point, meaning a point on a graph has an x part and a y part. So I found the x part, x equals 2. But now my goal is I need to find the y part. And that actually is easy, because if I know x equals 2, I can substitute it in either equation. I could plug it into that, or I could plug it into the top equation. It's up to you, but let's be smart. Let's choose the easiest one, which is that bottom one here. Y equals 2 minus 3, and 2 minus 3 equals negative 1. So that's my second answer, y equals negative 1. So my final answer that I write, like if I actually had to submit an answer for a solution to the system, there's one spot where the lines cross, and it's at 2, which is the x part, negative 1, which is the y part. So the point 2 comma negative 1 is where they cross. So that's how you solve a system using substitution. There's another method called elimination, which I'll do in another video, but this is specifically how you would do substitution. And that works for number 5. So like I said, for number 7, right, couldn't I just plug in negative 5 for y right here? So it would be 5x plus 4 times negative 5 equals 20, negative 20, excuse me. So it would be 5x minus 20 equals negative 20. And I would add 20 to both sides. And 5x equals 0. Divide by 5. X equals 0. So it makes it even easier when you already know what y equals. Because x equals 0. And I don't need to solve for y because what? Y is already solved. So these two lines cross at 0, comma, negative 5. That's the answer for this question. Okay? And now number 6 is something a little bit different, and even number 8. Okay? Notice how in number 5 and 7, y was already by itself, right? Y equals something, like y equals -5 or y equals x minus 3. But in number 6, y isn't by itself yet. Okay? And there's no reason why you have to start with y. You could start with x if you wanted to. So look at number 6. The equation that looks easiest is this one right here, x minus y equals 13. What you can do is try to get one of the variables by itself. So, okay, I'll add y to the other side. And then that would be x equals y plus 13. So see how I got x is all by itself, x equals something? What I can do is plug in that, because if x equals y plus 13, I can plug that in for x right there, which would give me 4 times y plus 13 plus 2y equals 10. Distribute the 4. 4y plus 52 is what that equals, plus 2y equals 10. Combine like terms, 4y plus 2y is 6y, plus 52 equals 10. Subtract 52 to get negative 6y by itself. And 6y equals negative 42. Divide by 6. Y equals negative 7. Alright, so I have the y part done, but now I need to figure out what x is. Luckily, I know y equals negative 7. I can plug that in right there. I can plug in any equation up at the top, but this one looks easiest. So it would be x equals negative 7 plus 13, which would be equals x equals 6. So my final answer, if I wrote it as an ordered pair, would be x is 6, y is negative 7. So I have the answer for that question. So that is how substitution works. And again, number 8, very similar to number 6. I'll get it started here. What I would do is subtract the first equation looks easiest. Subtract 7y here. And so x equals negative 7y. And then if x equals negative 7y, I can plug that in for x right there. All right, so that's how we do solving a system of equations with substitution.